Hi, this is the second example of solving a differential equation using series, the series method. So in series method, let's say the general solution for this differential equation, it can be written as y equal to a0 plus a1x plus a2 x squared plus a3 x to power 3 plus a4 x to power 4 and so on. Usually the problem, they will ask you to what order you got to go forward, and so all we have to do, we got to find the values for these coefficients. So since this is a second order differential equation, our answer is going to be in terms of a0 and a1. Then solving a real problem, having a differential equation like that, the boundary condition or initial conditions would let us find out the values for our a0 and a1. So the first step, again, to solve a differential equation using the series, we have to assume that our solution is y is summation of n from 0 to infinity of a n x to power n. So if this is the solution to this differential equation, let's go ahead and find the first and the second derivative of that. So the first derivative of that can be written as dy over dx is equal to summation from n from 1 to infinity of n a n x to power n minus 1. And the second derivative of that, d2y dx2 is equal to summation from n from 2 to infinity of n times n minus 1 an x to power n minus 2. Now we have the values for y, dy dx, and d2y dx2. Now we can plug these values in this differential equation, and we are going to have, this will be summation of n from 2 to infinity of n times n minus 1 an x to power n minus 2 plus x multiplied by dy dx plus x multiplied by that. So we are going to have summation of n equal to 1 to infinity n an of x to power n. Then this multiplied by y. First, x squared multiplied by y will be plus summation n equal to 0 to infinity of an x to power n plus 2. X squared multiplied by x to power n is x to power n plus 2. then plus summation n from 0 to infinity of 2 multiplied by an x to power n. 2an x to power n equal to 0. So this is our first step, and we apply the values in a differential equation, and we have reached this point. Now our next step is to write this in a form of bn x to power n. So to write this in that form, for the first summation, if we want to have n here rather than n minus 2, so our m is n minus 2. Therefore, the value of our n will be n plus 2. So if we apply that in first summation, we are going to have summation of n. n is n minus 2, so 2 minus 2, n from 0 to infinity of n, which n is n plus 2, multiplied by n minus 1. n is n plus 2 minus 1 will be n plus 1. N. So A or n is n plus 2 x to power n plus, so we have written our first portion in this form. Now the second portion, in order to write in that form, all we have to do, assume that n is equal to n. So it's going to be summation of m equal to 1 to infinity of n an x to power n. m is equal to n, so this is for the next portion, plus for this portion, in order for us to have x to power n, we have to assume that m is equal to n plus 2, then n will be equal to n minus 2. So here we have n equal to 0, so our summation will be n equal to 2, 0 plus 2, 2 to infinity of an, a, or n is n minus 2, x to power n. And for the last portion, again, our m is equal to n. So wherever we have n, we can change it to n plus summation n from 0 to infinity of 2an x to power n equal to 0. Now we have finished the second step, which we wrote everything in that form. Now the third step is for different values of n, we can find these coefficients. So let's go ahead and start. Let's go ahead and start with n equal to 0. By looking at these, we will see that the only summations that n can be 0 is the first summation and the last summation. So, so if we plug the 0 in these two summations, we are going to have 0 plus 2, which is 2, multiplied by 0 plus 1, which is 1. So 2 multiplied by 1 will be 2. A n plus 2. So a, we are getting n equal to 0, so will be 0 plus 2, so will be a2 plus, in the last summation, for m equal to 0, we are going to have plus 2 a0 equal to 0. So if we divide both sides of this equation by 2, the 2's will cancel out. So a2 will be equal to minus a0. So we have found the value for a2. Now, let's go ahead for and now let's go ahead and do that for m equal to 1. So m equal to 1 would apply only to this summation, that summation, and that summation. It will not apply to this because this summation is from 2 and up. So for m equal to 1, if we plug 1 in this summation, we are going to have 1 plus 2 is 3, multiplied by 1 plus 1 is 6. The 1 plus 1 is 2. So 3 multiplied by 2 will be 6. M is 1, 6, 8, 3, 1 plus 2, plus M is 1, so we are going to have 1, A1. So plus A1, and in the last one, we are going to have plus 2A1 equal to 0. So here, we are going to have 6A3 plus 3A1 equal to 0. So A3 will be equal to minus 3A1, will be minus 3A1 divided by 6. So A3 will be minus A1 divided by 2. So our A3 is minus A1 divided by 2. Now let's do it for, let's go ahead and do it for m equal to 2. So for m equal to 2 really applies to all the summation. This is from 0 to infinity, 1 to infinity, 2 and 0. So it would apply to all the summations. So on the first one, we are going to have, if we plug 2 for m, we are going to have 2 plus 2, which is 4, multiplied by 2 plus 1, which is 3, A4, plus m is 2 plus 2, A2, plus A0, this will be 2 minus 2, will be 0, plus 2A2 plus 2A2 equal to 0. So we have 4 times 3, a 2 plus 2 is 4, a4 plus 2, a2 plus a0 plus 2a2 equal to 0. So we don't need this anymore. We don't need this anymore. So here, this is 12a4 plus 2a2 and 2a2 will be 4a2 plus a0 equal to 0. So here we have 12a4 is equal to minus a0 minus 4a2, which we already find the value for a2, which is minus a0. So this will be minus a0 minus 4 times minus a0. So here minus times minus will be positive, so will be 12a4 will be equal to 3a0. So a4 will be equal to 3a0 divided by 12. So a4 will be a0 divided by 4. So our a4 is a0 divided by 4. Now we have the values for the coefficients, so we can go ahead and plug it in this form, in this general form. So if we do that, we are going to have y is equal to a0 plus a1x plus a2x squared, or a2 is minus a0 x squared plus a3 x cubed, or a3 is minus a1 over 2 x cubed plus a4 x to power 4, or a4 is plus a0 divided by 4 x to power 4, and plus so on. You know, in a problem they might ask you find up to the 5th power of x. So if they ask you that, then we have to go for another value of m and plug it in that formula and find the coefficient for the a5. So this is the answer. Last time I solved another example like this, and I believe understanding these two examples, you will be able to solve all differential equations like that using the series method. I hope you like that.